All right, today we're going to be talking about Chapter 8, Lesson 1. This is all about volume of cylinders. So if you recall from last year, with the volume of a prism, so the volume of the prism was the area of the base times the height. And in this case on the rectangular prism here, this right here was the base. So it'll be length times width is the area of the base times the height. So this was length times width times height was the very specific formula for a rectangular prism. But this one right here is the generic form for any kind of prism. Now, the good thing is a cylinder is actually a circular prism. The only difference is it doesn't really have any faces on it, except for these two bases. So if we look at this, the area of the base, this is a circle. So if we recall, the area of a circle was pi r squared. Now, in the past, we've used pi can be about either 3.14 or 22 over 7. This year, we're really going to focus on using the actual pi. So when we start looking at this, the volume of our cylinder is going to be pi r squared h. So the next thing we want to start looking at is example 1. Example 1 says find the volume of the cylinder and round to the nearest tenth. So formula is pi r squared h. In this case, r is the radius, which goes from, again, the center to the edge, and that happens to be 5.5 centimeters. And the height is from the top, again, to the bottom, so that would be 9 centimeters. So as I start substituting these values in, I have volume of pi. R is 5.5 centimeters. And we're going to square that because that's the area of the circle here. And then the height is 9 centimeters. So what I'm going to do is I'm going to use the calculator here. And I'm going to go through this step by step, showing you where each button is and how to use it. So, this first part, 5.5 squared. So 5.5. You can either use this button here because that'll get you a square. Or you can use this button here, but you'd have to use a 2 after that. Regardless, each one of those is the same. So 5.5 squared is 30.25. I'm going to multiply that by 9. So 272.25. Now, because we had centimeters squared here and centimeters here, that means this is going to be centimeters cubed. And if you recall from last year, whenever we have volume, that's in 3 dimensions, which is why this number here needs to be a 3. Now, this last part, right here is the pi button. So if we hit times pi, we get this answer here. So if we look at this, 855.2985999, and it would continue going on forever because pi goes on forever, but this ends here because it rounds. So it says round to the nearest tenth, which means we'd have 855 So this is volume is about 855. Because we're rounding to this number here, we want to look at this one here to see if it's 5 or more. And it is 5 or more, which means this 2 raises up to become a 3. So it's going to be 855.3 cubic centimeters. We use the about symbol because we're rounding. And that's how you do example 1. So example 2, it says find the volume width of a cylinder with diameter of 12 meters and a height of 4 meters. Round to the nearest tenth. So I'm going to draw a picture so I know what I'm looking at. So it says diameter of 12 meters. This is not drawn to scale. And a height of 4 meters. So my formula is volume equals pi r squared h, where r, so the diameter is 12, so the radius would be half of that, which would be 6 meters, and the height is 4 meters. So again, going through this, pi starts substituting values in, so 6 meters is my radius, 4 meters is my height. Using the calculator again, 6 squared is 36. So this is going to be pi times 36 square meters. Multiply that by 4. We get 144. Now because we've done meters squared times meters, this is meters raised to the third power, or meters cubed. And we're going to multiply it by pi again. So now we have 452, rounding to the nearest tenth, so we're rounding to this point. So this number is greater than 5, so this would go up to 4. So 452.4. So the volume is about 452.4 cubic meters. All right. Last couple examples here. It says example 3, a cylindrical container of ice cream is 10 centimeters in diameter and 12 centimeters tall. How long would it take for all the ice cream to melt if it melts at a rate of 2.1 cubic centimeters per minute, round to the nearest tenth? So, first thing we need to do is find the volume. I'm going to draw a picture. Diameter, it says, is 10 centimeters. The height, it says, is 12 centimeters. So the volume formula, again, is pi r squared h. R in this case, because the diameter is 10, the radius is 5, and the height is 12. So substituting values in, r again was 5, h is 12, 5 squared is 25, so this is pi times 25 centimeters squared times 12 centimeters. 25 times 12 would be 300. And then looking at the calculator here, 300 times pi is 942.5. Now, time to melt. So we want to get from this 942.5 cubic centimeters, and we want to get down to minutes. So we have this 2.1 cubic centimeters per minute. So we're actually going to want to divide by 2.1 cubic centimeters per minute. The reason why is because I want to get rid of this cubic centimeters. So if I want to get rid of this, I have to divide by cubic centimeters as well. So I'm going to actually leave this number on my calculator, and I'm going to simply do divide by 2.1. So this is a more accurate number. 448.8 minutes. So it would take about 448.8 minutes to melt. Now, if we were to get this rounded number, it would still get us there, but notice that this number was slightly different than what we just did. All right, last problem here, last example, volume of a composite solid. So when we want to do a volume of a composite solid, the first thing we need to do is divide into pieces we know. Then find the volume of each and add or subtract. So we have two cylinders here, large cylinder and a small cylinder in between. So large cylinder, volume equals pi r squared h. The diameter of the large is 13, so the radius would be 6.5. And the height is 28 centimeters. If I simply go ahead and do all of this in one shot, 6.5 squared times 28 times pi, this would be 3,716.5. Cubic centimeters. The small cylinder, same formula. In fact, same numbers. The only difference is the diameter is 4.5 centimeters, so the radius should be 2.25 centimeters. Otherwise, the height is exactly the same. So we have 2.25 squared times 28 times pi, 445.3. Next thing I'm going to do is, because this small cylinder is being taken out of the big cylinder, I'm going to subtract these two numbers. So 3716.5 minus 445.3 for a total volume of 3,271.2. So what I did was 3716.5 minus the 445.3. So my volume was 3,271.2 cubic centimeters. And again, this is an about because it is a rounded number. All right, so that is going to be the end of lesson 1. If you have any questions, please let me know.